Hello, good day everyone, and now let's proceed to the discussion of sedimentary and metamorphic rocks. By the way, I am Char Antirante, your reporter for this time, and together with me is Mr. Charm Vince Chavez, who helped me through the entire preparation of this presentation. And now, let's begin. First is the sedimentary rocks. Of course, sedimentary petrology is involved here since it focuses on the composition and texture of sedimentary rocks. Limestone, which consists of sedimentary particles bound together in a matrix or finer material. Here are the brief explanation of sedimentary rocks. First, sedimentary rocks are also called secondary rocks. If you're wondering why is it called as secondary rocks, it is because they are often the result of accumulation of small pieces broken off of pre-existing rocks. Second is that this group includes a wide variety of rocks formed by accumulation, compaction, and consolidation of sediments. It is formed in compaction and cementation of sediments, as what I've said a while ago. Compaction means what you might think like it is squeezing together, and cementation means like gluing or sticking together the sediments. And if we talk about its formation, sedimentary rocks are formed from the solid debris and the dissolved mineral matter produced by the mechanical and chemical breakdown of pre-existing rocks, or in some cases, from the skeletal material of dead plants and animals. By the way, there are four major groups of sedimentary rocks: the terragenous sedimentary rocks, chemical sedimentary rocks, organic sedimentary rocks, limestones, and dolomite. First is the terragenous sedimentary rocks, or usually called the clastic sedimentary rocks, which are formed from minerals or rock fragments derived from the breakdown of pre-existing rocks, or simply says, it is formed by weathering processes which breaks down rocks into pebbles, sands, or even clay. Another one is chemical sedimentary rocks, which are formed from the precipitation of salts dissolved in water. And for us to easily understand, these are the rocks that is made up of minerals that is precipitated directly from the water solutions. The third is the organic sedimentary rocks, which are formed from the skeletal remains of plants and animals and include coal and oil. Simply means it is the result of one's living material, like what I've mentioned a while ago, it is came from plants and animals. And the last is the limestones and dolomite sedimentary rocks, consisting of more than 50% carbonate and can include chemical, clastic, and biological material. And in its mode of transportation, or the sediments mode of transportations, are in glaciers, wind, water, and gravity. The wind running water and ice in the form of glaciers are the very strong and common agents of transport for carrying millions of tons of sediments and particles from one place to another, including seas and oceans. And now let's proceed to its examples. Actually, there are many examples of sedimentary rocks, but these five are the most common, which is the sandstone, limestones, shale, conglomerate, and breccia. Sandstone is a sedimentary rock composed of sand-sized grains of mineral, rock, or organic material. It also contains a cementing material that binds the sand grains together and may contain a matrix of silt or clay-sized particles that occupies the spaces between the sand grains. The picture in the presentation is a specimen of sandstone. For the information of everybody, it is approximately 2 inches or 5 centimeters across. Actually, there are many types of sandstone, but I only choose the siliceous, the calcareous, the argillaceous, and the ferruginous sandstones. Next is the limestones. These are the most common sedimentary rocks from the non-clastic group and are composed chiefly of carbonate of calcium with subordinate proportions of carbonate of magnesium. They are formed both biochemically and mechanically. There are two groups of limestones, which includes autochthonous and allochthonous. The difference between the two is that the autochthonous means which have been formed by biogenic precipitation from sea waters, while the allochthonous form from the precipitated calcareous sediments that have been transported from one place to another. The picture is a specimen of limestone, a dark gray fine-grained specimen of the Middle Mississippian Greenbrier limestone from Randolph County, eastern West Virginia. The specimen shown is about 2 inches or 5 centimeters across. Another one is shale. Shale is a fine-grained sedimentary rock of argillaceous composition. Shales are generally characterized with a distinct fissility parallel to the bedding planes and are made up of very fine particles of silt grade and to some extent of clay. Besides fissility, some shales show the laminated structure. The picture presented is both sedimentary rocks, and they are both detrital or clastic when it talks about its origin, and they are clay minerals, but only differ in their colors. Some of its types are residual shales, transported shales, quartz shales, and feldspathic shales. The fourth one is the conglomerate. Conglomerate is the clastic sedimentary rock that shaped from the rounded gravel and boulder size clast cemented or in a matrix supported. The rounding of the clast shows that rocks have been transported a long way from their source or on a seaside tide to wave movement. The specimen shown is about 2 inches or 5 centimeters across. It is made up of chert and limestone clast bound in matrix of sand and clay sized particles. And the last one is the breccia. It is a mechanically formed sedimentary rock classed as rudite. It consists of angular fragments of heterogeneous composition embedded in a fine matrix of clayer materials. As what you've seen in the picture, the angular class in this breccia are chert fragments. The matrix is an iron-stained mix of clay through sand-sized grained particles. It's also 2 inches or 5 centimeters across in size. There are 3 types of breccia: the basal breccia, the fault breccia, the agglomeratic breccia. The basal breccia is from or formed by the seawaters. The fault breccia is called crash breccia because they are made up of angular fragments. And the agglomeratic breccia, it is derived from the volcanic eruptions. Since we've done already discussing the informations and different examples of sedimentary rocks, let's proceed to metamorphic rocks. If in sedimentary rocks, sedimentary petrology is involved since it focuses on the composition and structures of sedimentary rocks. And also, in metamorphic rocks, metamorphic petrology is involved since it focuses on the composition and texture of metamorphic rocks, such as slate or marble, which started out as sedimentary or igneous rocks but which have undergone chemical, mineralogical, or textural changes due to extremes of pressure, temperature, or both. The occurrence of metamorphic rocks. Metamorphism. It is the term used to express the process responsible for all the changes that take place in the original rock under the influence of changes in the surrounding conditions of temperature, pressure, and chemically active fluids. Actually, it undergoes some sort of changes, which is the metamorphosis, as what I've mentioned a while ago, and it happens because the exposure of heat, very intense heat or pressure. Metamorphic rocks are defined as those rocks which have formed through the operation of stress minerals, various types of metamorphic processes on the pre-existing igneous and sedimentary rocks involving the changes in textures, structures, and mineralogical composition. Speaking of mineralogical composition, metamorphic rocks exhibit a great variation in their mineralogical composition that depends in most cases on the composition of the parent rock, the type and degree of metamorphism undergone by the rocks. Classifications of metamorphic rocks: foliated rocks and non-foliated metamorphic rocks. Foliated rocks is a special type of metamorphic rock that has distinct repetitive layers, while the non-foliated metamorphic rocks form around igneous intrusions where the temperature are high but the pressure are relatively low and equal in all directions, develop in environments where stress is minimal. In addition, foliated metamorphic rocks exhibit layers or stripes caused by the elongation and alignment of minerals in the rocks as it undergoes metamorphism. In contrast, non-foliated metamorphic rocks do not contain minerals that align during metamorphism and do not appear layered. For us to understand it more deeper, let's proceed to its examples. Examples of foliated metamorphic rocks. The first is the slate, the second is schist, and the last is the gneiss. Slate is a fine-grained foliated metamorphic rock that is created by the alteration of shale or mudstone by low-grade regional metamorphism. The common colors of it are gray, green, red, black, purple, and brown, but what you can see in the picture or on its example, it is a color gray. It is usually in the composition of mica, quartz, feldspar, calcite, pyrite, and hematite. Some of its uses are for roofing, interior flooring, exterior paving, dimension stone, decorative aggregate, as well as for chalkboards, billiard tables, cemetery markers, tabletops, and early electric panels. Another one is schist. It is a megascopically crystalline foliated metamorphic rocks characterized by a typical schistose structure. The constituent flaky and platy minerals are mostly arranged in parallel or subparallel layers or bands. It is usually in the composition of mica, quartz, and feldspar. Some of its uses are for host rock for a variety of gemstones filled when the physical properties of the materials are not critical. The dominant visible mineral in the schist that you've seen in the presentation is muscovite. Its plated grains are aligned in common orientation and that allows the rock to be split easily in the direction of the grain orientation. The specimen shown is still 2 inches or 5 centimeters across. The last example for foliated metamorphic rocks is gneiss. A gneiss is a megascopically crystalline foliated metamorphic rock characterized by the segregation of constituent minerals into layers or bands of constructing color, texture, and composition. Some of its uses are crushed stone for railroad beds, building foundations, and etc. And its composition are calcite, clay minerals, mica, quartz, pyrite, and other more. Non-foliated metamorphic rocks examples. It includes quartzite and marble. First is the quartzite. Quartzites are granular metamorphic rocks composed chiefly of intersutured grains of quartz. It is usually in the color of gray, pink, red, purple, yellow, orange, brown, green, and blue, and its only composition is quartz. It can be used in different ways, like in the construction, in architecture, in manufacturing, and a lot more. The picture that can be seen in the presentation is a specimen of quartzite showing its conchoidal-like fracture and granular texture. It is also in 2 inches or 5 centimeters across in size. And the last example is marble. Marble is essentially a granular metamorphic rock composed chiefly of recrystallized limestone that is made up of mineral calcite. Its compositions are a lot more, and some of it are small amounts of many other granular materials like olivine, serpentine, garnet, and some amphiboles. And it is usually in the color of light-colored rock, white, bluish, gray, pink, yellow, and black. And the Example that can be seen in the presentation is an example of marble which is in the color of pink. A piece of pink marble about 4 inches or 10 centimeter across. The pink color is mostly likely derived from iron. Thank you for listening, everyone, and I hope that you've learned a lot from our report about the topic of sedimentary and metamorphic rocks. Thank you.